Considering the amplitude of the currents at SPERT and HDA10, our findings suggest that MDMA and its analogs work as full substrates at SERT as partial substrates at HDA10. Furthermore, molecular docking studies have shown that MDMA and its analogs display similar binding poses when binding at SERT or HDA10. This result shows that the MDMA analogs preserve the same interaction pattern as MDMA despite the bioisosteric substitution of the methylene deoxy group. Interestingly, at HSERT, all interacting residues were shared between the compounds in 5-HT. However, at HDA, the compounds interacted with a larger number of residues compared to DA. Such finding is particularly significant as it suggests that the docked compounds have a higher potential to mimic the binding of the native substrate in HSERT compared to HDA, which is most likely a consequence of the higher structural similarity of these compounds to 5-HT as compared to dopamine, and supports our results with HSERT substrate preference over HDA10. The partial efficacy at HDA might arise from slow binding kinetics as shown already for the HSERT partial releaser PAL 1.4.5. Further studies will be necessary to evaluate the extent to which binding kinetics might be involved in the pharmacodynamics of the novel MDMA analogs, and whether slow binding kinetics might play a role for their in vivo effects as shown already for a range of other psychoactive substances. Given the unique psychopharmacological profile of MDMA, many other studies have explored the molecular pharmacology of other MDMA analogs and enantiomers and/or metabolitides and monoamine transporters. To our knowledge, this is the first study that investigated 3 novel MDMA analogs that reflected a bioisosteric replacement of the methylene deoxy group of MDMA and their analogs and enantiomers and/or metabolites of monoamine transporters. To our knowledge, this is the first study that investigated 3 novel MDMA analogs that reflected a bioisosteric replacement of the methylene deoxy group of MDMA and their impact on key molecular targets, together with a concomitant analysis of their impact metabolism. In our study, these bioisosteric MDMA analogs exhibited less potent and efficacious agonisticity at 5-HT2A, almost a 10-fold less potent activity in activating 5-HT2B and 5-HT2C receptors. For 5-HT2A, a weaker interaction with this receptor could translate in a reduced potential for muscarinic day release and reinforcing properties, together with the reduction loss of the hallucinogenic potential of these compounds at higher doses. Further studies will be necessary to confirm the reduced hallucinogenic effects in vivo, especially in relation to the 5-HT2A signaling pathways that might be involved. Importantly, the weaker agonism at 5-HT2B receptor by the MDMA analog suggests an improved pharmacological profile for the analogs with respect to MDMA, especially regarding the risk for cardiotoxicity. Nevertheless, evaluation on